In this lesson, we're going to find the solutions to two different equations. And what those solutions will tell us is where the graph crosses the x-axis, if it does cross the x-axis. And as you can see from both of these graphs, that does happen. So let's start with number 20. One of the first things we want to do to try to identify possible zeros or roots or solutions to this equation is to use the rational root theorem. And let's go ahead and write that down as step 1. The rational root theorem is a way to write and list out what all of the possible zeros are if they can be written as a fraction. We do that by using the ratio P over Q. Well, P is the constant term. That comes from above, that's 6. So we're going to list out all of the factors of 6. Those would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those factors will be over the factors of Q. Q is the leading coefficient. In this case, on number 20, that leading coefficient is 2. So the factors of Q are plus or minus 1 and plus or minus 2. What the rational root theorem does is it says that if one of the zeros can be written as a fraction, it will be here. It's somewhere in this. Maybe it's 2 over 1, maybe it's 3 over 1, maybe it's 3 over 2. We don't know yet. We just know that for a fact it has to be there. Step 2 is going to involve graphing. So step 2 has already been done for you. Lucky you. Step 3 is to begin checking for these zeros to see if they work. Well, looking at the graph, we can kind of judge what we think the zeros are. In this case, if we look up here, this looks like 3. And it turns out 3 is a real possibility based on the rational root theorem, the P over Q's. So I'm just going to say x equals 3, and I'm going to put a question mark, because that might be right. Over here, well, that looks like it's somewhere between 0 and 1, so it's probably a half. But, I don't really know for sure. So I'll just put x equals a half with a question mark for now. And then over here, we've got another one. Looks like maybe x is negative 1. And over here, it looks like possibly x equals negative 2. All of these, by the way, happen to be possible based on the rational root theorem, so they're probably pretty good guesses. Let's go ahead and start checking this, and we can do that by substituting in these values into the equation and seeing if we get 0 back out. If we get 0 back out, then we know it's a solution. Let's take a look here. So we can pick any one of these zeros we want. I'm going to choose some of the integer values first, maybe save that half for later. So now I could plug this directly into the equation, but in this case I'm going to use synthetic substitution. When I do that, I'm going to start with the 3 value. Now, of course, I'm going to use the coefficients from this equation, which are going to be 2, negative 1, negative 14, negative 5, and 6. Applying synthetic division, drop the first number down, take it times 3, write it up here. You always add the second row to the first. That's going to give us a 5. Times 3 is 15, plus negative 14 is 1, times 3 is 3. And plus negative 5 is negative 2. 3 times negative 2 is negative 6. Bingo, worked out. So, this means 3 is in fact a solution. It's a root. Now, you may be thinking, oh man, I don't want to use all those coefficients again. And you don't have to. Because we divided out 3, the factor associated with 3, what's left over is where the remaining zeros have to be located. So we can continue dividing or using synthetic substitution on the remaining zeros with what we had left over. So I'm going to do that. I'm going to use, let's go with negative 1 next. There we go. Drop the 2, take it times negative 1, we get negative 2, add 3, negative 3, negative 2, 2, 0. It worked. So negative 1 is also a root. I'm going to go ahead, take another one. Let's go with negative 2. Drop the 2. Take it times negative 2. Add. Get negative 1, 2, and 0. So that checks out. Only one more left. 1/2. Let's try that. Yep. So, our roots, the solutions to the equation, are 3, negative 1, negative 2, and 1/2. Now, let's try using the same concept on the second equation. I'm going to list my P over Q's. In this case, my P value is a little tricky. See, it's going to be the constant term, which there isn't one. So, in reality, your P is 0. So I'm going to have a 0 here. Then our Q is the leading coefficient, which is a 1. So this is going to be plus or minus 1. Well, what this implies is that the only rational possible root is 0. But we can see from the graph that that doesn't make any sense. It looks like it crosses at negative 8, and it looks like it crosses at 6. So this is a special case where if you see that the constant is 0, you want to try to factor out the x value. And then what's left over in parentheses, you could apply the rational root theorem again. Kind of weird, I know. So, what does that look like? If I have x to the third plus 2x squared minus 48x, the GCF is x. So I could write that as, let's go ahead. That's going to give us x, whoops, wrong one. X times x squared plus 2x minus 48. Now I could write a different P over Q. This time I'm going to use negative 48 as my P, and I'm going to use 1 as my Q. Well, here we go. I'm going to write this one in blue. So our new P over Q is going to be plus or minus. So again, our P is 48, negative 48, so we got quite a few of these. That's going to be 1, 2, 3. It's plus or minus all of these. 4, 6, 8, 12, 24, and of course 48. All divided by plus or minus 1. Now you can see that negative 8 or positive 6 are possibilities. Let's go ahead and use our original 0, and we'll test. So x is possibly 0, x is possibly 6, and x is possibly negative 8. So let's start testing these by using synthetic substitution. Skip the graphing, it's already been done. And if we take 0, now we do need to use the original equation to be thorough. So we're testing 0. And the coefficients were 1, 2, negative 48, and 0. Don't forget about that 0 in the end. It really is a constant, and it's part of the coefficients. Drop 1 down. 1 times 0 is 0. 2. Negative 48, and negative 48 times 0 is 0. It checks out. No surprise there. Now, let's see if 6 works. So go ahead and use synthetic substitution on what's left over. 1 times 6 is 6, plus 2 is 8, times 6 is positive 48. Yep, that worked. 6 is, in fact, a solution. It is a root of this equation. Now let's do the last one, negative 8. All right, 1, negative 8, and 0. Yep, it worked. So the roots are 0, 6, and negative 8. All right.